sometimes we need to find the length of a line segment, and if we know the coordinates together with that length, we must also be able to make a right angled triangle and find the area possibly of that triangle. So since when we've got two coordinates, we can make a right angled triangle. We're just using Pythagoras to find the length of the distance between them. So we'll be the square root of the height of this triangle, so 5 take 2 squared, plus the width of this triangle, 7 take 3 squared, so square root of 25. So 5. I'm not putting plus and minus because it's a length. We don't use negative length. It doesn't make sense to have a negative length. So the length of that line is 5. So in general, we could write that as a formula. Call that length d, the difference between them. So it's the square root of the difference between the y's squared, and then the width of the triangle, x2 take x1 squared, all square rooted. That's a general formula for the distance between two lines. We'll use that in a few examples. The three points of a triangle, I want to show that the triangle is isosceles. So an isosceles triangle has two equal sides. So to show it's isosceles, we should be finding the length of all three sides and show that two are the same. If we only show two of the sides, technically we've not shown it by that point because we could have an equilateral triangle. So we should find all three sides. So AB first. Square root of minus 4 take 2 would be minus 6, but then it's squared. And then minus 1 take 3 would be a negative, but it's being squared anyway, so we can ignore negatives. So 36 plus 16, square root of 52. I don't need to do anything more with that. I'm fine with that as it is. I just need to see if any others are also root 52. BC. So the height of it, 2 down to minus 8 is 10. And then minus 1 up to 9 is also 10. 10 squared plus 10 squared, so that's the square root of 200. So these two are not the same. So it must be CA. It's going to be the same as one of those. So for CA, we've got minus 4 up to 8, that's 4 squared, and then 3 up to 9, that's 6 squared. So it's the same as the first one. Square root of 52. So AB equals CA. So the triangle is isosceles. Okay, the next one, we've given the distance. So we've got the distance between these 2 points is root 65. And we're just finding the two possible values of x. Okay, so that root 65 has been found by square rooting the difference between these two, so x minus minus 1, and the difference between these two, 9 take 13, so minus doesn't matter, square root of 65. So if we square both sides, we get rid of the square roots. Change that to 16 now, and 65. So I just need to solve this. So we subtract 16. We're square rooting next. And that's why we're going to get two possible values, because now we're going to get plus or minus 7 from square rooting 49. And then we'll subtract 1. So minus 1 plus or minus 7. So that gives us the values of minus 1 take 7 1 minus 1, add 7. And that's it. Last one, split into two parts. So we've got the equations of L1 and L2, and we're told that they intersect at the point A. And first of all, we need to find the coordinates of that intersection. So to find intersections of lines, we should be solving simultaneous equations. We need to solve these two lines simultaneously. So the best approach to do that will be to rearrange them both, but rearrange this one to make y the subject and then substitute that into there. So for L1, we would get y equals 4x. So we can replace the y in the second equation by 4x. So 3 lots of 4x is 12x. Minus 21 equals 0. 14x equals 21. X equals 21 over 14 becomes 3 over 2. And then we can substitute that into the multiplying that by 4 gives us that y equals 6. Our coordinates of A are 3 over 2, 6. Part B, we want to find the area of triangle A, OB, where B is where it meets the where L2 meets the x-axis, O is the origin. So for line 2, when it's meeting the x-axis, that's where y is 0. We get 2x minus 21 equals 0. So 2x is 21 and x is 10.5. So we have coordinates 1.56 is A, 10.50 is B, and then that's what always. This is the triangle we're trying to find the area of. So we simply have to do half of base times height. Our base is 10.5 from the origin over to B. And the height of it is just how high A is up, which is 6. So that's 3 lots of 10.5, 31.5 units squared. Don't know what the units are, but because it's an area, we should say that it's units squared. So that length and area using straight lines. If you have a go at this exercise 5G from the textbook, and also in the booklet, there are some exam questions, 3 exam questions in total, to have a look at also.